Hi, I'm going to go through question 1 part J on Math 2018. And for this question, we just want to know which of these graphs could be given by an equation of this type, where p is a polynomial. Okay, so let's just take a second to think what graphs each of these looks like. So I actually think C and D are the easiest. So C obviously looks like a circle. And what's the equation of a circle? Well, it's just x squared plus y squared equals r squared, right, where r is the radius. And already we have something that looks very similar to what we want, except we need a 0 on the right-hand side and we've got an r squared. So we're going to want to take this r squared away, and that just gives us x squared plus y squared minus r squared equals the 0 that we want. But we need this left-hand side to be symmetric in x and y. So how can we distribute this r squared to get the same function of x and y on the left-hand side? And the easiest way is just to give half of the r squared to each of the x and the y, right? So we've got s squared minus r squared over 2 plus y squared minus r squared over 2, i.e. the p that we take is just x squared minus r squared over 2. So we see that C definitely can be given by an equation of this type. And as for D, we have a straight line through the origin with a negative gradient. And what's the simplest equation you can think of that looks like this? Well, for me, it just puts me in mind of y equals minus x. And of course, that's x plus y equals 0. So we can just take p of x equals x. So again, D is definitely possible. And so I've already worked out that C and D are both okay. So that already rules out A, B, and E. And I've just realised that I've written this option down wrong. I can't have both D and not D. This is supposed to be a B. Alright. So for both of these options, B is not a solution, which is good because it looks kind of funky and I don't want to have to deal with it. So now we just need to work out whether A is a possible solution or not. And actually, option C is the only one where A isn't a solution. So if we'd worked out that A isn't a solution from the very beginning, then we'd know immediately that it was option C. But let's work out A. So it kind of looks like y equals x squared or something like that. So I wouldn't expect it to be a solution. But we can also note that this is symmetric in x and y, right? If I swap the x and the y around, I still have the same thing. So what does that mean in terms of the graphs that it can produce? So what does swapping the x and y coordinates give us? Well, if I draw the line y equals x, if I take any point on one side of the line, then swapping the x and y coordinates would just give me its reflection in this line. So if we can swap the x and y coordinates, then that's just saying if we're given any points that's a solution to this equation, then its reflection in the line y equals x is also a solution, i.e. our graph must be symmetrical about the line y equals x. And of course A isn't, right? So that means A can't be a sketch of this curve, and so that rules out option D as well, which gives us C as our answer. Now, if you wanted to look at B, it's a bit more complex than the others. So if we look at this bit of the graph, for example, so on here, y must be constant. And if y is constant, then p of y must also be constant, right? But we also have from here that p of x is minus p of y, so that gives us p of x is also constant. So p of x is constant all along here, which means for any x in this range, p of x is constant. But it's also p of y is minus p of x, right? So it's really an if and only if. If p of x is constant, then p of y is also constant and vice versa. So if p of x is constant in this interval, then so is p of y. But we have all values of y in this interval, which suggests that p of y is constant for all y. So p is just some constant function, i.e. whatever we throw into it, we get some constant c out. But then to satisfy this equation, either we have that c is 0 and this is satisfied for all x and y, or c isn't 0 and this is satisfied for no values of x and y. So if we had a straight horizontal bit like here, then either all points would be solutions to this equation or no points would be. So B isn't a possible sketch. And that confirms that C is our answer.